Okay, before we start getting into this too deep, let's think about these ideas real quick. If I told you that an angle was cosine of 134 degrees, okay, so think about where 134 degrees would fall in the unit circle. Okay, so look at your unit circle. Which quadrant would 134 degrees be? If we're asking for cosine, would that be a positive answer or a negative answer? So if we're thinking cosine, I always think cosine, I'm thinking x value. Is your x value going to be positive or negative at 134 degrees? Well, 134 degrees would fall in the second quadrant. And in the second quadrant, your x values are all negative. So cosine of 134 would be negative. Okay, let's just kind of work through a couple more of these. Sine at 155.4. Okay, so think about that unit circle. Which quadrant would 155.4 fall in? Well, 155.4, look at it for a second. It'd be some angle kind of like that. So it's in the second quadrant. If you're doing sine in the second quadrant, is that going to be positive or negative? Well, again, sine means y. So if sine means y in the second quadrant, it's positive. Okay, try those last two real quick without me explaining them to you. Sine means y. We're doing 241.3 degrees, so I'm looking at my unit circle. 240 is down here, so 241 is probably something like that. So this would be in the third quadrant. Sine means y in the third quadrant. Oh, that would be a negative answer. And then the last one, cosine of 342. Well, 342 would be somewhere over there in the fourth quadrant. So if we're doing cosine, which is x values in the fourth quadrant, x values in the fourth quadrant would be positive. Okay, so that's a little bit of just a quick introduction, probably not too hard. We're going to use that today. So today we're using a new set of formulas. They're called the half-angle identities. Okay, these identities work no matter what. You can plug in any angle you want and it would figure these things out for you. Okay, so sine of alpha divided by 2 is going to be equal to this angle. Okay, cosine will be equal to that one. So it says find the exact value of cosine of 112.5 degrees. Okay, exact value means I'm going to use my unit circle. If I go to my unit circle, though, I'm not going to find 112.5 degrees. Okay, hopefully the thing that reminds you here is that there is a 0.5. Hopefully that helps you to remind yourself to think half angle, because that's what it is. It's a half an angle. So what we need to think, hey, it's 112.5. What angle does that go with? Well, if we took this angle, 112.5 is half of 225. Okay, if I took this angle and multiplied it by 2, it would get me 225. It's a half angle. All right? So with that in mind, we're using one of these two formulas. It's a cosine problem, so I'm going to use the cosine formula. So I'm doing the cosine. Well, what angle are we cutting in half? Well, we're going to cut 225 in half. So it's cosine of 225 cut in half. That's what 112.5 is. So let's plug in what we know. It's going to be equal to either plus or minus. It's not both. Square root of 1 plus. Right here, we're going to fill in what cosine of 225 is. Okay, that's what's going to go right there. So, looking at my unit circle, I'm going to 225 degrees. I'm doing cosine. So my problem will look like this now. Plus or minus square root 1. Cosine of 225 is a negative radical 2 over 2, all over 2. kind of an ugly problem here. We don't want to just stop here. We've got lots of fractions, and we talk about getting rid of fractions all the time. To get rid of fractions, what we can do is multiply by the LCD. Well, in this case, the LCD is 2. The only denominator I have here is 2. So I'm going to multiply every chunk here by 2. If I multiply this by 2, it gets me 2. If I multiply this by 2, those two things cancel. And if I multiply 2 by 2, it would get me 4. I still have a square root on bottom, because although it doesn't look like it, this is really the same thing as 2 minus square root of 2, all square rooted. And that 4 is underneath the square root, so it's really like the bottom is square rooted as well. So it's the square root of 4 on bottom. So real easy. We don't have to do a whole lot of work here to make that square root go away, because all we need to do is take the square root of 4 on bottom. The square root of 4 will just be 2. And then on top, I will have the square root of 2 minus the square root of 2. This is a really ugly answer. Okay? It looks really ugly, but it's fine. Our only rule is we aren't allowed to have a radical on bottom. This right here, there's a 2 underneath 2 separate radicals. It looks really ugly, but it's still fine. Okay? We're not done yet, because we need to go back and make a decision. Is my answer positive or negative? I have to make a decision. It's not both. It's either one or the other. And the way we make that decision is what we just did a second ago. Okay? The angle that we started with here in the beginning was cosine of 112.5. So all I need to do is think, where would 112.5 be? Which quadrant would cosine of 112.5 be? So look at your unit circle. Think about, where's 112.5 going to be? Well, that would be in this spot right here. Cosine of 112.5 would be in the second quadrant. So if I'm doing cosine, which means x, in the second quadrant, is that answer going to be positive or negative? Hopefully you know that that would be a negative answer. So my answer is negative. Square root of 2 minus square root of 2 all over 2. Every time we do these problems, they're always going to look the same. All right, let's try another one real quick. Sine of 22.5. So again, I see the 0.5, and I'm thinking, hey, this is a half angle problem. Which angle, when you cut in half, is going to get you 22.5? Well, that's really easy. Just take that number and multiply it by 2, and that will tell you what the full angle is, and that's what we need when we're doing the problem. If the half angle is 22.5, the full angle would be 45 degrees. Okay, so that's going to be important. This is a sine problem, and we're cutting it in half, so we're using that formula right there. So we're really taking the sine of 45 divided by 2. So when I set it up, it's plus or minus 1 minus cosine, notice that it is cosine, of 45 degrees. So I go to my unit circle. I'm going to write down what cosine of 45 is, which is radical 2 over 2, all over 2. The setup's pretty much the same every single time. We don't like how there's a lot of fractions going on, so we're going to get rid of some fractions by multiplying by that LCD. Multiply everything by 2. So 2 times 1 is 2, minus, those 2's are going to cancel, so it's radical 2, all over 4. It's the square root of 4 on bottom. So we can take the square root of 4 on bottom, because we don't want that square root on bottom anyways. So when I take the square root of 4, that would get me 2. On top, I really can't do anything with that. I don't know what the square root of 2 is, so I'm going to leave it. And I got that square root of 2 over 2. Super ugly. All right, but now we're going to finish this problem. It's not plus or minus. I need to make a decision. We are doing the sine of 22.5 degrees. So if I'm doing the sine of 22.5 degrees, I need to think about which quadrant would that fall in. So 22.5 degrees, that would be an angle something like that. so it's in the first quadrant. If we're talking about sine means y. So what's your y value going to be in the first quadrant? Is that positive or negative? That should be a positive answer. Okay, so probably not too complicated there. It gets you a pretty good start. It's pretty much the exact same thing every time. It doesn't really change that much. So once you get the hang of it, it should be fairly easy. All right, on the back side, we're going someplace a little bit different. We're going to establish the identity. So we're going back to proving that both sides are equal to each other, and we're going to use sum and difference identities, just like we've been doing. Okay, these actually are really easy once you get the hang of them. You just got to know where you're doing. So we look at this problem here. It's a sine problem, and we're adding. So we're going to look at our formulas up here. I've got sine, and we're adding. Hey, those are the same thing. So we're going to use this formula right here. Okay, so on this left side, I'm going to replace this whole thing with what we have up there. So we're replacing the left side. We're going to take this out and put this in its spot. So it's going to be the sine of alpha, which in this case is this pi over 2 thing here. This is my alpha. This is my beta. So sine of pi over 2. And then cosine of beta, which in this case is theta, plus cosine of alpha, which is pi over 2, and then sine of beta, which again is theta. Okay, and in the end, this whole thing should be just equal to cosine of theta. Again, although this looks really strange, it's not as bad as it seems. Once we've plugged in with the formula, now all we're going to do is evaluate this stuff. So sine of pi over 2. So you're going to your unit circle. You're going to pi over 2, which is up there. If I'm doing the y value up there, the y value for sine is 1. So it's 1 times cosine of theta. I don't know what cosine of theta is, so I'm going to leave it. Plus cosine at pi over 2. So again, here's pi over 2 again. I'm doing cosine. So that's the x value, so that's just 0 times sine of theta equals cosine of theta. I don't know what this is, so I didn't change anything about it. I don't know what theta is. I don't know what our angle is. So when we look at this problem, 1 times cosine, oh, that's easy. That's just cosine. Here, 0 times sine. Oh, if I multiply anything times 0, it's going to go away, so it's just 0. Cosine plus 0. That's just cosine equals cosine. Done. All right, so it looks strange, but again, look to see what we did. It says uses sum and difference identity, so we did. It was sine and was adding, so we picked the sine adding formula. We plugged pi over 2 in for alpha and theta in for beta, and then did a little bit of math. I did sine of pi over 2, which was 1, cosine of pi over 2, which was 0, and then see what happened. It should get you the same thing on both sides. Fairly straightforward problem. Okay, let's try one more of those. Establishing the identity using the sum and difference identities. So again, here it says sine of pi minus theta. And we're trying to make it equal to sine. So first thing we want to do is look at our sum and difference identities and look for the one that does sine and subtraction. Well, up here on the board, that's this fourth one down. It says that I can replace that with sine of alpha, cosine of beta, minus cosine alpha, sine of beta. And that's going to all be equal to sine of theta. This is my alpha. This is my beta. Sine of pi, because I know what my alpha is. Cosine of pi, sine of theta. Now we're plugging in sine of pi. Okay, looking at my unit circle. Pi is over here. It's the ordered pair -1, 0. So if I'm doing sine over there, that would get you 0. Cosine of theta. Cosine of pi would be just -1 times sine of theta equals sine of theta. 0 times cosine, that cancels. It's minus a negative, so if it's minus a negative, that changes to plus. So 1 times sine is sine equals sine Q E D. Done. Not too crazy of a lesson today, fairly straightforward on both parts. You just got to try it and see what's going on. For homework today, for the rest of the class period, I want you to complete these. Okay, so you got 3 problems on the front and 3 problems on the back. It won't take you very long. I expect them completed, and I want you to turn them in to the front tray when you get all the way done. I'll take that as a grade for today. We'll pass those back to you tomorrow, and then we will move on. So not crazy notes. Follow through. Help your neighbor if you need it, but it should be pretty straightforward. Thank you.